13. If a particle moves in a plane so that its position is described by the functions x equals a cosine of omega t and y equals a sine of omega t, the particle is, well, if all of these questions are about speed, then you might want to consider the fact that the position can be derived to get the speed, so that the x component of the velocity should be negative a omega sine of omega t, and the y component of the velocity is equal to a omega cosine of omega t. And so, if you want to get the speed by the Pythagorean theorem, that's going to be the square root of the two components squared added. Now, a little algebra is going to tell you that this is just a omega times the square root of sine squared of omega t plus cosine squared of omega t, and of course the argument inside of the root is equal to 1, so your speed has a constant value, a omega. Now, if it's constant and the position is along a circle, because the position is given again by the Pythagorean theorem as x squared plus y squared, and that's equal to a times the square root of cosine squared of omega t plus sine squared of omega t, then we know that the position describes a circle of radius a. All of the positions are around this circle, so it is a circular path, but the speed is constant. The best answer then is option A.